Alright, so this is the second revision of Headnode that I've done where I was BPS manager. So I was the manager of BPS last school year, up until when I left for Ireland, and then I also helped out with BPS a lot over the summer during our. So you'll notice here just on this page, if you watched my last video, things are very different. And if you haven't watched my last video, I'd recommend it. I'm not gonna everything. I just kind of want to cover some of the changes I mentioned had on this revision video and explain why they did, how they impacted the board, and what I learned from them. So you'll see here that things are just overall emptier, and so that's a good thing. So we'll go through each different schematic page and talk about what we changed. So firstly, on the connector page, we still have all the connectors for the board and also the power circuit. But you'll notice that now this power circuit is the exact same as button, board, and HAL. So this was part of the standardization effort that we had make things across the boards to both make managers' lives easier and implement. So we just include a lot of the quality of life changes that we. I'm not going to repeat myself here. If you want to see me talk about this a little bit, go to the button, board, or HAL video. I don't think much on the connectors changed. Like I said, you can see we still have these flyback diodes here, and we also have not much changed here. Oh yeah, so we did remove some of the charging stuff here. Some of it is still a redundancy. We really just need the array switch F on here, so we could remove more of it, but like I said, left it on for now. We just parts. Nothing over here from what I understand. I have the power board one on there, and I think we added a tiny 10 picofarad capacitor between. This might have been on the last rep. This is also just to help smooth it out. Since that button's latching, as we press it or unpress it, it's going to waver a little bit, and so this capacitance is to kind of help, smooth out that changing voltage as we press it down, since this affects the car when the battery pack off. So it's pretty important. On the interface page here, you'll see some differences and just stuff we removed. You'll see here that we took out the XOR circuit for external charge enable, and so that's because that's software controlled. We still have the array enable on here, which still uses the array trigger and the external charge trigger, which uses all the same logic. And our similar logic to power start enable remains the same. We want to keep this implementation exactly as we had before, but we just wanted to kind of cut the fat on the rest of the board for things we did. And so like in my last video, I talked about buffering 5 volts to power board and precharge. So I got rid of the NPN transistor because I barely use them for precharge. Now it sends a 5 volt charge, and power board also uses a 5 volt signal. So we did flip how the microcontroller powers this. So now logic on will be when this enable pin is 0 volts, but with the benefit of software, they can easily change that in the code to invert really easy. And so now, since power board will still need a 12 volt signal, power what it needs, it the enable to recognize that, oh hey, the battery pack relays are closed, we can start pulling power from it. It buffers that 5 volt signal, we send it 12 volts. So we also just, like I said, removed some of the MOSFET buffers stuff. Module board interface, you'll notice that we had the 0 ohm resistor for the analog fault out 5 volt line removed because we always want that connected and it's well enough. We don't have an issue with it. You also see here for the fault line receiver, we changed this to a MOSFET and an NMOS to be specific, so that whenever this returns here, like I said, just because we want to get rid of BJT, we don't use them in the rest of the car. It's kind of silly to just use 2 in the car because then that's just one more thing we have to order that we don't. So yeah, and it's pretty nice here, pretty straightforward. For the regulators, you'll see that we switched to the switching regulator for the application board. So same exact circuit here. We have the pull up and pull down resistors to adjust for the voltage drop on D5. I've already talked about this circuit a bunch of times, so I'll repeat myself again, but we just make a note that we are making circuits. You'll also notice that we have that 2.5 volt reference regulator removed because we did not use it on the last revision at all. It is just a remnant from old architecture. that we don't use anymore. The compute page is a lot smaller. So the exact same pins are connected here. We just got rid of the old compute module block that controls our microcontroller, which is that big block in our PCB. It was designed by one. So it's actually a PCB that solders into these pin headers. And yeah, so they just had an old revision because Headnode's been worked on for a couple of years now, and we just updated it. And it's a lot easier to read. And all the other boards use this one, like button board or how videos. So it's great because it's a little standardized now. And you'll notice as a common theme, many things are not drastically changing. This is how it should be for a lot of these boards going forward now that they work better. We just want to have small changes to improve performance, remove things we didn't need, just to clean things up. And so that's what we did on this rev. And I was really happy with it. It was nice to do that for 2 consecutive, I guess, and see that improve. So this page did not change much except for the output. So in the last video, you'll remember that we had 2 0-ohm jumpers going to relay enable and the power switch MOSFET enable. I think it's a little silly that I don't know why I called them relay enable ports. That's something I must have messed up, but well, I don't know. I guess it's okay, but all the charging names of the ports get a little redundant here because we have charge relay enable, which is a microcontroller charge relay. That's something someone could do in the future. You also notice that we have one AND gate here, where before I thought we had, but that might be wrong, but it's ANDed with start enable and the microcontroller relay enable signal. Also ANDed with 5-volt line. That might have been something we just added to make getting power to the boards, but that might have been on the last rev to remember. And then we have the same power switch circuit. I think I may have added a capacitor. I might have just moved around. The circuit didn't change much. We also have a circuit to measure the currents. Don't actually do anything with this, but it's just poured on there. But then we have the relay control lines, which are then outputted connector page as seen. But we just don't have the choice of using the relays or the power switch on Headnode to power the battery pack, like here. But yeah, so shorter video. I can talk about the design a little bit too. So we use the same PCB as before. We just made changes where needed. So you'll see now that we have the power switches on the top of the board instead of the bottom, and we move them to where the relays were. We also, so we do just have one AND gate. So I think we did change that. So we have one AND gate here controlling, it's a 3 input, 3 AND, like 3 in a package, and they're 3 input. And so, yeah, that's what you, and so have these resistors and capacitor to power each of these. It's a little more straightforward, especially with the S points up here. We kind of followed the same idea of horizontal on the top layer, vertical on the bottom. Power circuit here got a little fuller. We have the new switching regulator boards. A lot of the stuff over here just kind of got deleted. Any traces that were related to parts that we moved. And we didn't really touch much of this. I think if you wanted to improve this board, I'm pretty happy with how the left side of it is. I think you could clean up some of this. Maybe, spread the parts out down here to over here. Maybe move these connectors over a little bit because this part's a little choked up. But, the board's in a working state and we removed a lot of parts on it, so I'm pretty happy. But that's about all I have. I have this updated revision also on GitHub on my website, and I have a write-up of changes. But in general, this is a shorter video because a lot of easy changes. And so these quality of life changes are kind of what I would hope to see going forward on the team. They aren't as interesting, I guess, maybe to work on. Still learn a lot about the system, but when we're incrementally developing new cars and stuff into our, it needs to be small changes like this. Have something that, so I think we need to put an effort in doing that, and I think we did a really good job of that last year. But thank you so much for watching. Hopefully I post more in the future. If you like what I've done, I have tons of other content, both for Solar Car and my personal project, things I like. Go watch that, but